No! No! No!
I wonder how balloons could be related to calculus.
Alrighty, gamers. So we are going to be doing question 20 first, and first we're of course going to be doing part A before part B. Now I know what you're thinking. What is question 20? Well, question 20 is a spherical balloon is inflated with the helium at a rate of 100 pi feet per minute cubed. Now, part A states, how fast is the balloon's radius increasing at the instant that the radius is 5 feet? So, we got some equations here. We know that the volume, these SweetTarts are volume of a sphere is 4/3 pi r squared, cubed, not squared. And we know that dv over dt, or the rate that volume is changing with respect to time, because we respect time, is 100 pi, because that's what the problem told us. So first, let's find the derivative of this equation. So we got dv over dt equals 4 pi r squared dr dt. So, since we know that dv over dt is 100 pi, we can plug 100 pi in. Over here, we got 100 pi equals 4 pi. Oh, and then also, we can plug 5 in for the radius, because the question specifically states whenever the radius equals 5. I'm going to plug 5 in for the radius, 5 squared dr dt. Now, you need 5 squared, of course, is 25, as we know, times 4 is, of course, 100, as we know. So then we have 100 pi dr dt equals 100 pi. So to finish off part A, all you have to do is 100 pi divided by 100 pi to get the equation equal dr dt. And that equals a very nice and crisp dr over dt equals 1 foot per minute. Okay, so next we're going to be solving part B. Part B states, how fast is the surface area increasing at that instant? Now, the instant it is speaking of is whenever the radius equals 5 feet. So, we got some equations to work with. This is going to be a toughie. So, we got surface area equals 4 pi r squared. And we also know that dr over dt is 1 because we solved that in part A. So, let's find the derivative of this. Because the derivative is going to be how fast it is increasing, right? So, we got derivative of surface area with respect to time equals 8 pi r dr dt. Now, we can plug some numbers in after we do this. We can plug 5 in for r because it says at the instant that the radius is 5. We can also plug 1 in for dr dt because we solved that in the first question. So, now we can do some basic arithmetic. 5 times 1 is obviously 5. And then we can do that number, which is 5, times 8. And then we get the derivative of the surface area with respect to time equals 40 pi feet squared per minute. So this means that the surface area is increasing at a rate of 40 pi. Thanks for watching my TED Talk. Oh boy, I wonder how coffee relates to calculus.
Oh, didn't see you there. Well, while I'm here, I'm going to do question 24 out of our calculus book. So, part A of question 24 starts off, coffee is draining from a conical filter into a cylindrical coffee pot at the rate of 10 cubic inches per minute. How fast is the level in the pot rising when the coffee in the cone is 5 inches deep? So, let's start off going over what we're given. We are given that the derivative of volume over time is 10. we are given that radius is equal to 3. We are also given that the derivative of radius over time is 0. So we know that the volume of a cone is equal to volume equal to pi r squared times h. So we can then do the derivative of that to get dv over dt is equal to 2 pi r dr over dt times h plus dh over dt times pi r squared. And then we can plug all of the numbers we were given earlier into the equation. And see, we did that right there. And then after this, all of these numbers then cancel out, so we are left with 9 pi dh dt. And after we then plug in 10 for dv dt, we can divide 10 by 9 pi, giving us 0.354 inches per minute. Okay, after that short commercial break, we're back, and we're going to be solving Part B. Part B states, how fast is the level on the cone falling at that moment? So, let's go over what we're given. So we know that the volume of a cone is equal to pi over 3 times r squared times h. We also know that the derivative of volume over time is equal to 10. So what we need to do now is we need to find r in terms of h. So if we take r divided by h, we get 3/6, which reduces to 1/2, which gives us r is equal to h over 2. So now we can plug that in for our volume formula, giving us volume is equal to pi over 3 times h over 2 squared times h, which is equal to pi over 3 times 1/4 times h squared times h. Okay, so we can then find the derivative of volume over time, which is equal to pi over 12 times 3h squared times dh over dt. We can then simplify that down to pi h squared over 4 times dh dt, and we can then plug in 5 for height, giving us pi times 5 squared all over 4, which then goes to 25 pi over 4, which we can then divide 10 by 25 pi over 4, giving us 0.509 inches per minute.
Oh boy, guys! Now we know calculus! Let's go!